Buenos dias. Welcome to the fourth video on the physics, the energy topic on work and power. The last video we looked at was on conservation of energy and efficiency, and as we said, they are really important topics. Conservation of energy in particular will be coming up quite a lot over the next couple of videos. So this first video, the first section, is on work. So what is work? Well, work is the same thing as saying energy is transferred. Whenever energy is transferred, we can say work is done. Whenever work is done, energy gets transferred. In physics, in a physical point of view, this is actual physical work, mechanical work. It's not mental. So in terms of you sitting there listening to this video, working your way through the questions on the worksheet, in physics, that's not considered work. It's only work is only done when you move against a force or when you use a force. So work done equals force times distance, and you've got the formula triangle there. Again, I'm not going to go through any examples there. You can pretty much work that out for yourself. It's pretty straightforward. Now, I just want to spend a little bit of time looking at a little bit of a kind of complexity when it comes to these questions. As we said, doing work involves transferring energy. That's important. But when it comes to an exam question, you might have to think on your feet. Sometimes the exam questions, in fact, fairly often, the exam questions will be fairly straightforward. They'll give you a force, they'll give you a distance, and they'll ask what's the work done. Sometimes, however, they don't seem to give you enough information. So I've got this example. A car's travelling with 200,000 joules of kinetic energy, 200 kilojoules of energy. Calculate the work done by the engine. Now, that question will come up and people will spend an age staring blankly at the page, expecting something else to jump out at them. They know that work done is force times distance, but the question is only giving them an energy. It's not telling them a force, it's not telling them a distance. So how can they work out the work done by the engine? Well, it comes back to this idea about work being the same thing as transferring energy. Think about this. If a car has 200 kilojoules of kinetic energy, that kinetic energy must have come from somewhere. The car has not magically made that energy appear. That energy must have come from the fuel. It must have been given or transferred by the engine. So if a car has 200 kilojoules of kinetic energy, the work done is 200 kilojoules. The engine has transferred 200 kilojoules of chemical energy and transferred that into kinetic energy. A slightly more common example is the brakes. So the car exam question again would say the car's travelling at 200 kilojoules or with 200 kilojoules of kinetic energy. The car comes to a halt, calculate the work done by the brakes. And again, the same thing holds true. So if the car has 200 kilojoules of kinetic energy when it's moving, when it's stopped, it will have no joules of kinetic energy. That energy will have been transferred by the brakes. So if a car's got 200 kilojoules of energy to start off with and it comes to a halt, the brakes will have removed or transferred that 200 kilojoules of energy. So the answer again is 200 kilojoules. So a little bit of advice: if you ever come across a work done question and it gives you an energy but gives you no other values and asks you to calculate something, you just write down what the energy value in the question is. Try and move that up a little bit more. Okay, and we just need to mention this idea about work and friction, because again, this tends to be the one that they talk about a little bit more. So, work is often done against friction. On Earth, whenever anything moves, there will be friction, whether that's straightforward friction, or whether that's air resistance or water resistance, the object will be experiencing friction. Now, in those cases, the energy is transferred as heat. So as a quick example, rubbing your hands. When you rub your hands together, friction tries to stop your hands from moving. When that happens, thermal energy is transferred. The chemical store in your hands, in your muscles, is transferred to kinetic energy, and that kinetic energy is transferred by friction as thermal energy. So when you've got friction, you've got heat being given off. Car brakes, something similar is what we've already talked about. A car's driving down the road. It has 100 joules of energy. When the car brakes work, the brakes work to get rid of that kinetic energy, and it transfers it to thermal energy. This idea about dissipates is just this idea that when the brakes work, that thermal energy is dissipated into the surroundings, into the air. It spreads out. And that leaves us with our last idea, which is this one of power. So we've talked about work. Work is just basically transferring energy. Power sometimes is used to mean the same thing, but it is slightly different. Power is how quickly you can do the work. It's how quickly you can transfer the energy. In terms of the physics exam, how they describe it is the rate of energy transfer, but the rate of energy transfer is the same thing as saying how quickly you can transfer energy. It's measured in watts, and just like joules, watts is a very small unit, so we tend to use kilowatts. Couple of examples: a kettle. Kettles are quite a powerful appliance in your kitchen. It will transfer a lot of energy to the water very, very quickly. A less powerful kettle will do that slowly, and so therefore it will boil water slower. Cars are a little bit easier to understand and get your head around because you see it all the time. A less powerful car will get you up to 60 miles an hour, but it might take you 10 seconds to do that because it transfers energy in a slower rate. A more powerful car will still get you up to 60 miles an hour, however it will do that faster. So your 0 to 60 might be 3 seconds. Further on from that, a more powerful car can reach a higher top speed because at higher speeds you are working against air resistance. So if you have a powerful car, the car's engine can work against that resistance, that friction, faster, and therefore you can reach a higher top speed. In terms of the formula, we've already said this before, if you're working out the rate of something, you divide it by time. So power equals work done divided by time.